Yeah.
So for the one where we were removing stuff, did we have to delete the node that we were in?
Anytime you're removing a node, if you don't delete it, your program will still work, but it's a memory leak.
Okay.
So what would happen is your node will stay in the heap, and then if your program gets used for a long time continuously, the heap will build up, and pretty soon you'll start running out of memory. But it's difficult to detect because your program appears to be working correctly.
Okay.
That is a really is everybody?
How do we know?
Yeah, well, I mean, there are debugging tools that actually show you pictures of the heap that actually can monitor the heap but it's difficult because your program apparently works fine. Do you see what I actually have an article in the an article on memory leaks, I think, on the course webpage that talks about I think it's a case example of a famous memory leak. So the professionals, memory leaks happen in professional software all the time, for that very reason, because they're difficult to detect. So you say, how do we know? Oh, I don't know, because it's hard to detect. Anyway, today we are going to learn a really important object-oriented design pattern called the visitor pattern, right? And the reason we are doing this, let me ask you a question you probably don't know the answer. What are the 3 goals of this course? To learn data structures, to learn object-oriented design patterns, and to learn C++ programming. And Java, yeah, right. We're going to preface this by saying it's possible with pretty low probability that a library would provide a linked list using the composite state pattern, but the odds are virtually infinitely nil that you would do a linked list using the visitor pattern on top of the composite pattern and the state patterns. Because this is way complicated. So why are we doing it? Because of the second goal of this course, to learn object-oriented design patterns. Okay, that is the purpose of this exercise. It's not because it's more efficient, it's not because it's easier, because it's not, it's harder. But the goal is to learn how this object-oriented design pattern works. So we're going to spend a bit of time here at the high level explaining why this design pattern is important and where it's used and why it's important for us to understand the concepts of how it works. Now, I'm going to do a little show and tell here, okay? So this is the book. It's by Eric Gamma, Richard Helm, Ralph Johnson, and John Vlasides, okay? And it's Design Patterns, Elements of Reusable Object-Oriented Software. Probably the most cited book in all of software literature. And this visitor pattern that we were talking about is the very last one in the book. There's a whole number of them. They categorize them as creational, structural, and behavioral. And if you go to the internet, you Wikipedia or whatever, and you do object-oriented design patterns, you do the visitor pattern, there's all kinds of stuff about it because it's used all over the place. Now, this next slide is a quote from that book. So what does the visitor pattern do? It says, represent an operation to be performed on elements of an object structure. Visitor lets you define a new operation without changing the classes of the elements on which it operates. Now that second sentence is the primary one of the quote. Visitor lets you define a new operation without changing the classes of the elements on which it operates. Now, why this is important is because this visitor pattern is the basis of all plug-in software architectures. And I know that you guys know what plugins are, because anyone who has ever used a browser, right? What do browsers have? They have plugins. You know, you have a plugin to do this, a plugin to do that, okay? Photoshop, for those of you who do visual stuff. Photoshop, you know, is a big program. The host program is Photoshop. And what you can do is it lets you manipulate, you know, manipulate images, right? And it is based on a plug-in architecture. So not only can you buy Photoshop and use it, you can also buy plugins from independent developers that plugs into Photoshop to process an image a different way, a certain way, however the plugin, you see, and you can have different processing, you know, for different, just by buying a plugin. And NetBeans itself, we are using NetBeans as our IDE. Have you noticed that if you go to Tools and then you go to Plugins and you can see what plugins are installed? You know one of the plugins that we are using in Photoshop is the C/C++ plugin. So you see, if we didn't, I mean, so NetBeans by itself doesn't provide the capability of processing C programs. But what happened is an independent developer, well, not wholly independent, these guys work really closely together, but independently of NetBeans itself is the plugin that gives us the capability to use NetBeans in this new way. It adds functionality to NetBeans. Now, so do you see then that this is widely used? This is probably one of the most important design patterns there, you know, because of this capability. And so these are 3 examples of where plugins are used. Okay? So now, just think about this. Let's just think about this with NetBeans. Suppose that you had NetBeans and it didn't have the C++ capability. Now, if it was not based on a plugin architecture, then what would you have to do? To get C++ capability in NetBeans, you would have to get the source code for NetBeans and the source code for the C++ capability and compile them into one executable, so then you would have a program that would give you NetBeans plus the C++ capability. Do you see what we're saying? I mean, for example, let's say this linked list. Suppose in the linked list, suppose you wanted to have in your linked list library, suppose you wanted to be able to like shuffle the elements of a linked list. I mean, you know, so instead of having 1, 2, 3, 4, 5, here, like suppose instead of having the list be 1, 2, 3, 4, 5, 6, 7, 8. Suppose you wanted to have like a shuffle capability that would give you what? 1, 5, 2, 6, 3, 7, 4, 8. See? Shuffle. 1, 5, 2, 6, 3, 7, 4, 8. Well, obviously, our library doesn't have the shuffle capability, right? We don't have a shuffle method. We don't have a shuffle thing in our library, all right? So if you didn't have a plugin architecture, what you'd have to do is to provide that shuffle capability for the user, what would you have to do? We'd have to go make a new shuffle method. Are you with me? Implement the shuffle method, recompile the whole thing, give it to the user, and then the user would have shuffle capability. You understand how we would have to do that? I mean, how in order to give the shuffle command to the user of the linked list, that's what we'd have to do. All right? But with plugins, you don't have to do that. If the app is based on a plugin architecture, you can actually write a shuffle method and just do it as a plugin, and you don't have to recompile anything. You don't have to recompile the host. You don't have to recompile it. That's amazing. You understand what I'm saying? That's huge. Yeah. Now, of course, no one commercially would do this with a linked list because linked lists are just very small. But for large applications, for browsers, for IDEs, for Photoshop image processing, for these big applications, for these big large applications where you cannot anticipate what all the users are going to want to do, then what happens is you build it as another word for this is framework. Okay, these used to be called frameworks. Okay, but everyone's used to now plug-in architectures. Okay, but it's the same thing. Okay, so look at this advantage: ability to add features to an application without modifying and recompiling the class library. So plugins can be supplied by third-party developers, and even the end user could write a plugin. Yeah.
How do you get how do they get the info? Like if it's already compiled and everything, like how do they know, like, oh?
How do they? That's what we're going to answer. It's a little complicated, and we are going to answer. We are going to answer that. We're going to show you how to do that. How they do that? Because how can you do that without anticipating? How is that possible? It is possible. I'm going to show you. Stay tuned. Here we go. Yeah, that's the whole point. That's the good question. That is the numero uno question. In fact, here's the problem. You just identified the problem. How to allow here's what we need to do. How to allow a user to write an arbitrary method. See, because we can't anticipate, whether it needs shuffle, whether, you provide shuffle, he's going to want something else. We can't just keep recompiling, compile. Okay, so how to allow a user to write an arbitrary method that has access to the underlying data structure of the application, and we don't even know what for example, to add a new function, a new method to a list, we cannot even anticipate what the parameters would be for that new function. You understand what I'm saying? We can't anticipate. How do we know this? Do you know what we mean by the signature of a method? What's the signature of a method?
The attributes.
No, I'm talking about a method. What's the signature of the method? Did we ever define that? What's the signature of a method? Yes, it is the number and the types of the parameters. Are you with me? So we cannot anticipate the number of parameters, the types of the parameters. We can't provide a dummy method that has these parameters, and then another dummy method that has these an abstract method, another abstract method, and then you just do these abstract methods however you want to. We can't anticipate. You see what I'm saying? We can't anticipate. One user might want a non-void method with no parameters that returns a value of some type. Another user might want to write a void method with several parameters. What would the parameters of this be if this shuffle? I think it'd be no parameters, right? The parameter list would be empty, and you'd say my list dot shuffle, and then when you do my list dot shuffle, my list would turn this list into this one. See? Or what if you want to do one merge? What if you want to say merge? What if you had two lists and you wanted to merge them? Well, then that one of the parameters would be another list, and you'd say my list dot merge your list, and that would merge them somehow. Okay, but you don't know. How do you know what the user's going to want? So, here's how it's going to work. Here's the solution. Now, you guys, I have this, and right off the bat, let me say, this is complicated. This is more complicated than anything we've done before. What we're going to do is we're going to use the visitor pattern on top of the composite pattern and the state pattern. Okay, but this is about as complicated as it gets. This is the last design pattern in here, and if you can get this, you're good to go. Okay, but I'm just saying it's going to get, but why are we making it more complicated? Because we want to learn how the visitor pattern works. Because that's the second goal of this course. Okay, so now here's the scenario, and I'm going to give a diagram here. It's not in the slides or in the book. And let's work through the solution. So here's the solution. Wait, before we start, let's understand, let's also get the scenario. I know that in this situation, you as an individual are developing a single application in NetBeans with this project. But the whole idea is that in industry, the way it's used, there are three different people involved. There are three different people, and so let's just think about this. Let's think about like let's think about Photoshop with Photoshop plugins. One individual for Photoshop is the developer of the Photoshop application itself. So the Photoshop, that would be called the host. So there's the host developers. These are the developers that develop the host system. All right. Then let's just think of it as a third-party plugin developer. So the plugin developer is the one who uses the host system provided by the host to develop a plugin, to write a plugin. And then the third person involved is the user, the person who buys the plugin and uses it. So do you understand that in order for all of this stuff to make sense, you got to keep in mind that there are 3 different people. And in this case, what I'm saying is, in this case, it's all the same person. You are doing, but for this whole thing to make sense, it's this, we're going to learn how these people can act independently of each other, even though for you, these roles are merged for us in this particular one. All right? So, let's read through this. Here's the solution. The host system provides, now check this out, a minimal complete set of operations that any plugin developer can use to build the desired plugin. Are you with me? That's what so let's draw a picture. So here, this is the host. All right? And if this were a UML diagram or whatever, this would be, you'd have the name and the attributes and blah, blah, blah. And what does it say the host system provides? A minimal complete set of operations. So here's, now, and the developer can use them. So are these going to be public or private? They're going to be public. So plus, blah, 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 plus, blah, 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 plus, blah, 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 blah. And these right here are operations for whom? For whom are we? Whom are we?
For the plugin developer.
For the plugin developer. Are you with me? So these are operations for the plugin developer. Operations for plugin developer. All right. Now, what else does the host system provide? Now, who's writing all this? These are the host developers, all right? What else does the host system provide? It provides a what? What does it say next? An abstract visitor class with methods for the plugin developer to implement. So look, here's the picture. So here, now who is providing this? The host system is. The host, like Photoshop is providing this. You see what I mean? The Photoshop developers are providing this. So this is, the host is providing this. And what is this class? This is an abstract visitor class. Abstract visitor class. Are you with me? All right? And what's in this abstract? It might have some attributes, whatever. But what's one of the things that it's going to have? It's going to have what? Methods for whom? The plugin developer to implement. So here, and because the plugin developer is going to implement them, what do they have to be? Public or private? They have to be public, so the developer can. Okay, so plus blah 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 plus blah 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 blah. And what are these? These are methods. These are methods for the plugin developer. And then there's one more thing that the host system provides. What is this? What's the last one? A what? A public method named what? Except. For whom? The end user. Now that's the third. Are you with me? That's for the user. So here, up here in the host system, plus except. Okay, so that's a method up here that the host system. And for whom? The end user. So this one's not for the plugin developer to execute. This is for the end user. So this is for end user. Now, is everybody clear? Does everybody see the scenario? All right? So now watch this. So host is providing this, host is providing this, this is what the host provides, right? Now let's take a look at it from the point of view of the developer. What does the plugin developer do? The plugin developer writes a plugin by declaring a visitor to be a what? Subclass of the what? Abstract visitor class. So here I am, now I'm a developer. I want to write some function, I want to write like a shuffle method for, you know, the list or whatever, okay? So what does that plugin developer do? Well, this is available by the host system. So what does the plugin developer do? The plugin developer writes a plugin. And what is a plugin? The plugin code that the developer writes, it is a what?
Subclass.
It's a subclass. It inherits from this. Are you with me? So this, so who writes this? Who writes this? The host doesn't write this. Who writes this? Plugin developer. So the plugin developer writes this, and this is a visitor class, right? So let's suppose that the plugin developer writes some plugin called my plugin visitor. So he's going to call it my plugin visitor. Okay, so he writes his name. This might be like the shuffle plugin, right? So my plugin. Now, you guys, these are pure virtual, right? They are abstract. So obviously, what does the plugin developer have to do? The plugin developer has to do what? Has to implement these to do the task that he wants the plugin to do. Are you with me? Is everybody clear? So these, you know, whatever these are, he has to take these. Oh, no, yeah, that was right. Plus, and the plugin developer, what he does is he implements the methods as specified up here, right? So implements the abstract methods. Let's say that implements abstract methods. Now look, you guys, now here's another key idea. When the plugin developer is implementing these abstract methods, what does he have access to? He's going to have access to these. Are you with me? When the plugin developer is just I don't know how to indicate that on the diagram, but just let's see. When the plugin developer implements, he's going to have access to these operations, this minimal complete set of operations. Well, we'll see.
Okay.
We'll see.
Of course.
Yeah. All right. So he's going to have access to these. I'll show you a more complete, detailed UML diagram of the whole setup in a minute. All right. Now, so that's the host. Here's the plugin developer. Now let's take the point of view of the user. So now here's the user. So implements the visitor methods that the abstract visitor class provides. So how about the plugin user? So here's the user.
All the users are sort of set.
Oh, we should make this a little up. That's a happy user. Here's a happy because the user gets to do shuffle. Okay. So let's suppose this is a shuffle. So now the question then is, how does the plugin user do his thing? What the plugin user does is he instantiates a specific visitor object. So here in the user's code, he would do something like this. This is like my plugin visitor. He would say my plugin visitor. That's the type. And then the name of the variable, let's use lowercase m. My plugin visitor. Are you with me? So you see that this is what we mean by instantiates a specific visitor object. Are you with me? And now you guys, here comes the key idea of how this thing, why this thing can work the way it does. Here comes the magic. And then in the user's code, what the user does, now what do you think he calls here? For the end user, you see. So the user does this. The user says, accept parentheses my plugin visitor. That's what the user says. The user says, accept, he says, oh, here's my plugin visitor, and he says, accept my plugin. Now, why can he call accept? Because, why can the user call accept? Because accept is one of the what? One of the methods by the host pre-compiled. Are you with me? Pre-compiled. Nothing in the host has to change. Pre-compiled. Are you with me? Accept. We're going to see the code for accept. It's fixed. It is fixed. We can compile it and distribute it to our user community. Are you with me? So the plugin developer is not changing the code for accept. Are you with me? But look, what is this thing? What are we passing? Are we passing an int? Are we passing a double? Are we passing a list? Are we passing the list that we want to have shuffled? No. What are we passing? We are passing a what? A visitor. Passing the visitor object as a parameter. This is a visitor. But what does this object have? This object has what? This object, what does this object have? It has what? It has these methods. It has these methods. So what happens is, we come up here, accept, boom, this is going to accept the visitor, but this visitor has these methods. And who wrote those methods? The developer wrote the methods. See, here's where it comes. Here's how we can do it. The developer wrote the methods. All right? So see how that, see? So the visitor gets passed, accepts the visitor. But now what happens is, you see, we are passing an object, a visitor, to accept, and accept is going to execute, and accept knows what to execute because accept is saying, I'm going to execute these. But this guy implemented those. Now this is way cool. This is just way cool. If you can get, did you see that scenario? So the host executes accept, which in turn executes a method implemented by the plugin developer. See, because an object has methods. But we can pre-compile accept, and we can pre-compile this abstract visitor class. We can pre-compile it and make it available to the plugin developers. That is the visitor. That's the scenario. Yeah. Okay. Now what we're going to do is we're going to show you the details of how that works. But this is the overall. This is the overall story. And now we're going to go into the details. But you got to keep this overall story in mind, or nothing will make sense. Yeah.
So it will accept then always take as a parameter like an object?
It will not only just an object, it will take a visitor object. A visitor object. That is a very good question, and that is the heart of this whole thing. Accept, provided by the host system, will always take a visitor object. And that visitor object will be a concrete visitor that the plugin developer wrote. And see, the plugin, here's the key. The plugin developer can implement these methods, all right? These methods and the signature, you see, because the signature of these methods that the host provided are fixed, compiled ahead of time. You see? Okay, so, all right. But the plugin developer can implement them any way he wants. So that's the hook by which the host can execute code that someone else wrote, but that code was not pre-compiled in the host system. This can be compiled separately. So here's what's going to happen. In your projects, now your projects are going to get really complicated, because now what's going to happen is every method is going to be its own file. Do you see what I'm saying? These plugin methods, each one of them is going to be its own file. So now you're going to have a file for this, you're going to have a plugin for this, a plugin for this. What used to be all integrated into here, now we're going to re-implement them as plugins. And you say, oh, it's so complicated, why do I have so many files? Well, but the whole idea is the second goal of this course, to learn how object-oriented software design, object-oriented product. And it's way cool. Is everybody, you see how this, is everybody clear on this? Now let me just give one more idea before we delve into the details. Look, you guys, remember we said that one of the original problems was we don't know what the parameters should be. Remember we said, how do you know whether you're going to need parameters or not? Well, look, one of the things that you can do when you subclass something else is what? One of the things you can do is do what? You can do what? What can you put here that's not up here? What can you put here that's not up here? Attributes. You can add attributes.
So that would be like when you're creating the My Plugin Visitor over there, you would, like on the top line, you would put in things there.
Yes, yes. So what the thing of it is that the plugin developer is free to add whatever attributes the plugin developer wants here. And the host system doesn't need to know that. So what corresponded to parameters in the non-plugin architecture, they become what? Attributes. They become attributes, because we can add them without recompiling any of this. And that's how you can customize your plugin. It's the ability to add the attributes. It's how you can customize your plugin to require all sorts of input and give all sorts of output, and unknown to this, unknown to the host. I tell you, this is way cool. Yeah.
Could you theoretically create a plugin for a plugin?
Oh, that's a good question. Actually, what we are going to do is we are going to have plugins that use other plugins. It's possible for a plugin to use a plugin.
Okay.
Yeah, and I'll show you how to do that. I'll show you how to, yeah.
So the attributes that the plugin developer
Can add, can specify.
Where do those come from? Is this just like from their...
No, well, it depends on the application. It depends on what the plugin needs.
Okay.
You see? So like if you wanted to merge two lists, then you might have then one of the attributes would be a list. And then the user would have to give the list. You see?
So it doesn't like correlate to whatever is defined.
Yeah, I think at this point what we need to do is see how, but once you have to get the overall picture. All right. So now, you guys, but now this should look familiar. This is this. Are you with me? Now let's take a look and dissect this. Okay, so you see what we've outlined here. There's the host system, and you see the host system. Now for us, what we're going to do is we're going to apply this visitor pattern to the composite state design pattern of the linked list. So this is going to be, our project is going to be list CSV, which stands for a composite state visitor. So do you see now, what do we have? The top part of the figure. You see we have a list CSV and an abstract CSV node and a non-empty CSV node and an empty CSV node. Do you see that? Okay. But look, you guys, we don't have every single one of those methods in our list anymore. We only have a minimally complete set. Let's look at what we have in our list CSV. we have some constructors and destructors. And what are those two key ones there at the beginning? Except. And what does this except take? It takes a what? An abstract visitor, a visitor. So you see that corresponds to the fact that except takes a visitor, and it's provided by the host. You see that? Except those two, a constant version and a non-constant version. All right. And now, what are the minimally complete methods? Copy head first, operator gets, prepend, rem first, and rest and set list. You can do anything with the list with just those 7 methods. That is a complete set. Anything that you want to do with the list, you can do with those. So the host developer, the host system has to provide that. Has to determine what's the minimally. What would a person ever want to do with an image? Well, the person would have to have access to this and this and this, and whatever they want to do with it, then they can do that. You see, so those are provided. And now what's going to happen is, and now let me hasten to say now then that in that list CSV, those methods, the first and operator gets and rem first and rest, all those are exactly identical to the list CS project. Do you see what I mean? Those are just the same. So there's nothing different there. All right? Okay, and furthermore, the ACSV, that's exactly the same. Non-empty CSV, that's exactly the same. Empty CSV, that's exactly the same. All right, so there's nothing new there. All right, but now what about this part right here? Not only does the host system provide that, what else does it provide here? A list CSV viz. So the first A is what? Abstract list composite state visitor pattern viz. Right? And what are these little things, the methods for the plugin developer? Now, what do we have? We have empty case, non-empty case, and then a constant version of the empty case, and a constant version of the non-empty case. Are you with me? See? So as all the plugin developer has to do is implement empty case and non-empty case. That's what the plugin developer has to do.
This is different than what we did before, though, because like it decided if it was empty or not empty, but now you're having to implement the fact that it is.
Well, before, actually, here's what happened before. Here in comparison to what happened before. Before, remember, we had 3 methods.
Right.
We had the list method, the empty node method, the empty node version, and the non-empty node version.
Right.
What happens now is, in this visitor pattern implementation, what we're going to do is the host system is going to do the list version. Mm-hmm. And we basically, all we have to do is replicate the empty case and the non-empty case to do what we did before with the empty node and the non-empty node.
But since they have different names, you still have to call specifically which one.
Well, now that's a good question, and who calls whom? This whole thing works by what's known as a callback. So what happens is the plugin developer implements empty case. The plugin developer never calls it.
Okay. Wait.
Nor does the user call it. The user executes except. It's the host system that calls.
Okay.
So the plugin developer is writing a plugin for which the plugin developer never executes a call to it. Okay? And now you guys, the plugins, so now what's going to happen is empty is going to be a plugin. Clear is going to be a plugin. Max is going to be a plugin. Do you see? So these are all going to be separate. We're going to implement these separately as plugin developers. All right. So here is a close-up version of the top. And like I said, I think this part is all just the same as we had before, with the exception of what? We have 2 what? Excepts. One for the, why we need a non-constant and a constant version is because, we don't know if the user is going to use this with a constant list or use it with a non-constant list. And C++ requires us to have, for the types to match, to have both versions. Usually the code is the same, except in the case where if it's a mutable one, you try to do change a constant list, then you have to implement a precondition violation. See, because, so that's just a little C++ thing that we have to deal with. All right? And by the way, here, let's go back to this overall one. We have a new relationship here that we haven't done before in UML. This is this UML terminology. You see that dashed line that's going from list CSV, and what does it say there on the way down? Use. And then boom, and it goes to here. Now this is the use relationship. Now, can you see why this is the use relationship? Because this A-list CSV viz, where is that used? That's used in list CSV as the type of visitor in the accepts. Do you see? It's not an attribute. You know, a visitor is not an attribute of list CSV, but you see list CSV uses it in the parameter list of accept. And this is the UML way notation to denote that. Is everybody clear on that? Okay, so that's a new little UML thing. All right, and then here's a close-up of the abstract list CSV viz class. And basically we have an empty case and a non-empty case, and then the plugin developers, they subclass their plugins from this abstract visitor class. And now look, you guys, now remember what we said about this? What did we say about the attributes? The plugin developer is free to do what? To add attributes. So look, what is one of the attributes of what attribute got added to LCS viz empty LCS? Sorry, oh, that's a hard one. LCSV is empty viz. Yeah, you see what I'm saying? It's I have a hard time naming these, but it's all consistent. LCSV is empty viz. What is its attribute? Underscore what? Result, which is what? Bool. Why do we need that attribute? Because is empty does what? Returns a Boolean. We got to have a way to return a Boolean value. You see? So even the return value, if it's going to have a return value, we make it an attribute. Make it an attribute of the plugin. Are you with me?
So these, previously, like in the node, I don't know how good it is to keep comparing them to the nodes that we were doing, but like we had empty node and non-empty node, and those are like types of abstract nodes, right, or subclasses?
Yes.
So is this kind of the same thing? Like you have a empty visitor and a non-empty visitor?
No, you do not have an empty visitor and a non-empty visitor. You have a plugin visitor, and this plugin, one plugin implements both the empty case and non-empty case method.
Okay. So each one of these has within it an empty case and a non-empty case.
Yes, and you see these are implementations of these. Are you with me? Like this just specifies the signature. These are the abstract ones are pure virtual. They're slanted. You see how that's slanted font? So in C++, those are going to be pure virtual. It's going to be virtual blah 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 equals 0. And then these implement them, and so we'll say override. You see what I'm saying? So what the plugin developer does, the plugin developer just has, the only thing you have to do as the plugin developer is just implement those to do what you want. But see, but look, here's another thing. Max, what did Max return? Something of type T, right? So what do we have as a attribute? Underscore result, constant T. So that's our result is going to return type, a value of type T. So that's going to become an attribute. Okay? And then here's the max helper viz.
So it's like all of the things that were previously like methods are now like classes.
They are plugins. They are plugins, and they get used. Here's how the user uses the plugin. Okay, so here's a little description of the UML dependency relation, that dashed arrow. The client is, this is a UML terminology. The client is list CSV, the supplier is A-list CSV viz. The relation is the client depends on the supplier. It depended on it by using it as a type. You see what I'm saying? So it needed that class because it used a type. So here's where, in fact, here's where it is. I've outlined it here. So list CSV uses a list CSV viz as a parameter, so it depends on a list CSV viz. Do you see with that? That's the dependency relation. Are you with me? And the primitive methods for list CSV are implemented exactly as they are for list CS. All right. So now here, you guys, here is, watch this. This is the code for accept. This is the code for accept. Look, what does this is in the host. Accept, void list CSV. Accept, now what does accept take as a parameter? A what? A visitor. So you see that is the type visitor, abstract visitor. But now the way we did things in our thing, what did the list do? It said, I don't know if I'm empty. I don't know what to do. I don't know. So what does it do? Underscore head arrow what? Except.
It's in itself.
So it has the empty node version and the non-empty node version. All right. Now what this host is going to do is it's always going to pass star this. Are you with me? Because we don't know ahead of time whether it needs to or not, so it won't hurt to pass it so that it needs it if it. So I mean, even though it might not need, even though the node version might not need to know the owner, we'll give it access to it anyway because it might. You see, so that way it'll work in both cases, whether it needs it or not. We'll give it. We'll have it. Does everybody see that concept, that idea? And now look, you guys, here it is. Visitor. I think I have. Here it is. Visitor.empty case what? Owner. Okay. So look. Do you see that what we have underlined here is visitor got passed as a parameter. Are you with me? And then in the list version of accept, visitor got passed as a parameter. Now what does the list version do? It not only passes star this, it also passes the what? The visitor. Are you with me? To the node version. But now look at the node version. So now what does the node version have? The node version has a parameter called owner, and it also has a what? A visitor. So what does accept do? It does what? What does this do? It does what? Visitor.empty case. Because what is visitor? It's an object. It has methods. So do you see, this is where it's executing the methods that the plugin developer wrote without having to recompile.
But the plugin developer put in the cases, has
yes.
for empty case and non-empty.
Yes.
And then originally it goes to either empty or non-empty, and then it only uses the empty ones.
Yes. Right. And the plugin developer knows that that's what's going to happen.
Yeah.
The plugin developer knows. And this only has to be, this can be written without knowing what the attributes are, what the signature is, you see what I'm saying? See, look, we've never had this before. You're taking a parameter as an object and you are executing its methods. Because an object has methods. It's executing, this is a parameter. It's executing that parameter's methods without having to recompile, without having to know what they are. It can call it without having to know. It can be a proprietary. It could be, proprietary code. You wouldn't know. The host doesn't know. Yeah.
So the methods that we had before, like clear and max.
Yeah, yeah.
But they're not methods. They're plugins. Those plugins are not being called right when this happens. So you have to do that, or when.
Well, wait. What you can do? Here's what you can do. You can compile. The plugin developer can compile the plugin with the abstract visitor class and supply that to the user, and then once that gets installed, you know how you install a plugin. Once that gets installed, so that the host system knows what that plugin is, then the host system can call that and execute those without knowing what that source code was. Because accept takes an object with methods as a parameter, and then uses that object visitor dot empty case, and passes on owner.
Yeah.
So that's the, and then there's the const version is the same thing, okay? And now we'll continue this tomorrow.
So like,